Next, we're going to start to talk about the rules of differentiation and finding derivatives. These are rules that you are going to have to memorize, except the trig inverse rules. I give you those on exams. But you're going to have to know how to use them, and it's really, really helpful if you have them memorized. It just makes everything go so much faster, okay? So, let's look at the derivative rule for constants, right? So if I have f of x equals c, then the derivative of a constant is always going to be 0. So if I have, and why is that? So let's take f of x equals 7, right? So I would have, if I took the limit of this first constant, the limit as h goes to 0 of x plus h, so I'd have 7 plus h minus 7 over h. That gives me 0 as my derivative, right? My 7's cancel out, my h's, got h from 0 over h, those cancel, I'm left with 0. So the derivative of a constant is always going to be 0. So f prime of 7, f prime of x is 0. In this case, f prime of x is negative 3. And in this case, f prime of x is 0. Next, let's take a look at the power rule. This says if n is a positive integer and I have f of x equals x to the n, then f prime of x is n times x to the n minus 1. So what does that even look like? Let's look at examples. So here I have f of x equals x squared. So f prime of x would equal, this is my n here, 2, would equal 2 times x to the 2 minus 1. So I get 2 times x to the first, which is just 2x. Let's try this again with x equals 100. Okay? If I have f prime of x equals 100, because that's my n, x to the 100 minus 1, so I have 100 times x to the 99, right? So what we're doing here is we go down by 1 degree every time, and this makes sense, right? Because when we were taking limits before, we were dividing by x minus h. We're dividing by one of the x's, right? So we're going down 1 degree. We saw this when we found the derivative of f of x equals 3x squared minus 4x. Using the limit method, we saw in a previous section, its derivative was 6x minus 4. Now this is a little more complicated than what we're doing right now, but it's what we're building up to. So let's take a look at this last problem. F of x equals x to the 17. I have f prime of x equals 17x to the 17 minus 1, which is 17x to the 16th. So that's our power rule. So now we have a constant rule and we have a power rule. So we also have some difference in constant multiple rules. So these rules are very similar, right? What these rules say is that if I have a function, I can break it up into its pieces and find its derivative. So we can pull them apart into their pieces using the difference rule that we used for limits and take their derivatives. So f of x is really 5x cubed minus 2x squared plus x plus 7. So I can take the derivative of each of these little pieces and combine them. So the derivative of 5x squared is 15, 3 times 5, x to the 3 minus 1, which is 2, minus 4x plus 1, and the derivative of the constant goes to 0. Let's go through some more examples. f prime of x equals 4 times negative 2, which is negative 8, x to the 4 minus 1, which is 3. Here I have x to the first, right? 1 times negative 8 is negative 8. X to the 1 minus 1 is x to the 0, which is 1. So that's why that becomes a constant. F prime of x equals negative 4x cubed plus 6x squared, and that negative 2 goes to 0. Here are the formal definitions of the sum, difference, and constant multiple rules. Let's go ahead and talk about the product rule. The product rule says that if I'm taking the derivative of a product, right, I take the derivative of the first times the second, and the derivative of the second times the first. So f prime of x equals dx, right? We're taking the derivative of x squared plus 2 times 5x minus 3 plus the derivative of 5x minus 3 times x squared plus 2. So f prime of x equals, the derivative of this is just 2x times 5x minus 3 plus the derivative of 5x minus 3 is just going to be 5, because this goes to 0 and this goes to 5, times x squared plus 2. We should go ahead and simplify this. So I have 10x squared minus 6x plus 5x squared plus 10. So I have the derivative of this is 15x squared minus 6x plus 10. All right, let's try this again. So I have the derivative of this. This is the derivative of my first term. Times 7x plus the derivative of my second term times negative 2x cubed plus 5x minus 1. So I have f prime of x equals negative 6x squared plus 5 times 7x plus 7 times negative 2x cubed plus 5x minus 1. And what you're going to want to go ahead and do is distribute. So I have negative 6x. Nope. I have negative 6 times 7, that's negative 42. X squared plus 35x minus 14x cubed plus 35x minus 7, and then you need to combine like terms. I'm going to stop because I'm out of room. All right, let's see if this is the same as the constant multiple rule. So I have f prime of x is the derivative of our first term times the derivative times 8 plus the derivative of my second term times x to the fourth minus 6x. So I have f prime of x equals 4x cubed minus 6 times 8 plus 8 plus 0, the derivative of 8 is 0, times x to the fourth minus 6x. So I'm going with the f prime of x equals 4 times 8, 16, 24, 32, x cubed minus 6 times 8, which is 52. That is not right. 4 times 8 is 32. 32 plus 16 is 48. There we go. Much better. Next, I want to discuss the quotient rule. So as long as my numerator and denominator are differentiable functions, then the quotient rule says if I take the derivative of my numerator times the derivative of my denominator minus the derivative of my denominator times my numerator, over my denominator squared, that's going to be the correct derivative. So I have, in this case, f of x equals d dx times f of x plus 2 times 6x squared minus 3 minus the derivative of 6x squared minus 3, 5x plus 2, all over 6x squared minus 2. So I have f of x equals 5 times 6x squared minus 3 minus 12x times 5x plus 2. And be sure to distribute that negative all over 6x squared minus 3 squared. Now what you're going to need to do is you're going to need to distribute, you're going to need to square the denominator and fully simplify these problems. So let's try a little bit of an easier one. If I have 5x equals 3x over x squared, this is definitely differentiable, right? Both of these are differentiable functions. My derivative is going to be 3 times x squared minus 2x times 3x all over x squared squared. So my derivative is 3x squared minus 6x squared over x to the fourth. So I have negative 3x squared over x to the fourth, and that's going to simplify to negative 3 over x squared. Here, my new denominator is my numerator is a constant. It is definitely differentiable, but that's going to mean when it's differentiated, it goes to 0 because of our constant rule. So f prime of x is going to be 0, 5x cubed minus 2x minus 15x squared minus 2 times 7 all over 5x cubed minus 2x. So you can already see that this first term is going to cancel. You can distribute and fully simplify. Now let's talk about the extended power rule. So the extended power rule extends the power rule to negative integers, right? So before, if I had f of x equals 3x squared and I wanted the derivative, I would take f prime of x equals 2 times 3x to the 2 minus 1. So my derivative would be 6x to the first. I'm going to do the same thing for negatives. I'm going to distribute my negative integer and subtract 1. So the derivative of x to the negative 2 becomes negative 2x to the negative 2 minus 1, which is negative 2x cubed. The derivative of x to the negative 100 becomes negative 100 x to the negative 101. And the derivative of negative x to the negative 1 is negative 1 times x to the negative 1 minus 1. So I have negative x to the negative 2. That's our extended power rule. It's also important to note that we can extend the product rule. We can extend the product rule by taking the derivative of our first term times our second two terms, then the derivative of our second term times our first and third term, and then the derivative of our third term times our first and second term. So when I write this out, that'd be 3x squared times negative 3x squared plus 4x, 5x minus 3, plus, see we're finding the product, so we're adding, plus x cubed plus 2, the derivative of my second term, which is going to be negative 6x plus 4 times 5x plus 3, plus x cubed plus 2, negative 3x squared plus 4x times the derivative of 5x minus 3, which is just going to be 5. And then it's up to you to fully simplify that bad boy. So have fun.